Okay, good day viewers. Thanks for watching. In our today's class, I want us to learn redox reaction. But before we go very in depth in redox reaction, I want us to understand the concept of redox reaction. Right? There are three things I want us to understand here. First thing is definition, definition of oxidation and reduction. Second is half half equation. Third, oxidation number calculation. Oxidation number calculation. Fourth is the main redox reaction, or should I say to steps to redox reaction. So in this video, we are going to focus on definition of oxidation and reduction. We'll focus on definition of oxidation and reduction in this video because I want us to take it precept upon precept, line upon line. I don't want us to rush into this because it is I won't say it is a broad topic, but it is a heavy topic in chemistry that requires attention. It requires careful attention. Now, let's talk about definition of oxidation. So under definition of oxidation and reduction, under definition of oxidation and reduction, under definition of oxidation and reduction, we have four key words that explains the definition very well. It can be defined in four ways. The first one is addition of oxygen. Addition of oxygen. Second one is removal of hydrogen. Third one is addition of electronegative element. Addition of electronegative element. Fourth one is transfer of electron. Okay, let's start out with this addition of oxygen. I don't know whether I should write or just focus on the solving. Under addition of oxygen, I want us to know that oxidation here is addition of oxygen, while reduction here is removal of oxygen. Now, how can we understand that? Example. This is where you need to pay careful attention. Let's use copper 2 oxide. This is copper 2 oxide, right? Plus copper 2 oxide plus hydrogen gas. This copper 2 oxide, is it a solid or a liquid? Is it a solid or a liquid? Huh? If you are to balance this equation, we are going to have copper solid, and we are going to have water here. Now pay careful attention. Pay careful attention. Here, eh, remember we said that addition of oxygen is oxidation. Is that correct? There's oxygen here, but here there's no oxygen here. Did you understand? Here we have in the reactant side, or should I say on the reactant side we have hydrogen gas. But on the product side we have water. So from here to here, let me reduce this. Eh? Let me shift this because I will don't like this dirt. Okay. From here to here is oxidation. Why from here to here is reduction. Now let's review this. How? Remember we said that oxidation is addition of oxygen. Look up. Remember we said oxidation is addition of oxygen. Is that correct? Copper 2 oxide. This copper now, this compound has oxygen in it. But here it has been reduced to metallic copper. To metallic copper. Do you understand now? We say that copper is reduced to metallic copper on the product side. Then eh, water, hydrogen is oxidized. Okay, let me say copper is reduced to metallic copper on the product side since oxygen has been removed from it. Since oxygen has been removed from it, in bracket. Here water is oxidized in the product side since water is oxidized in the product side. Why is it oxidized? Because oxygen was added to hydrogen. So we call this, what do we call this? Is this oxidizing agent or reducing agent? This copper oxide. We call this oxidizing agent. And we call this reducing agent. Now, let's study why is it called oxidizing agent? Because oxygen was removed in the product side. And here, this one is called reducing agent because oxygen was added in the product side. Not just that. Oxidizing agent is any substance that is reduced in a chemical reaction, thereby bringing about what? Oxidation. I repeat, I'll write it somewhere here. I think I need to clean this. Let me clean here. What is oxidizing agent? Oxidizing, oxidizing agent. Oxidizing agent is any substance that is reduced in a chemical reaction or equation, thereby bringing about oxidation. Did you understand? So, if you observe now, we have copper oxide. Eh? We call it oxidizing agent because it is a substance that is reduced because it is reduced in the polar side. The copper oxide was reduced to metallic copper on the product side since oxygen has been removed from it, because we were told by our definition that oxidation under addition of oxygen is that oxidation is addition when you add oxygen into a compound void of oxygen. It is called what? So when you add oxygen to an element void of oxygen, it's called what? Oxidation. While reduction is when you remove oxygen from a compound containing oxygen. It is called what? Reduction. Did you understand? So the one that brings about reduction is oxidizing agent. Another way around. The one that brings about reduction here is oxidizing agent. While the one that brings about oxidation here is the reducing agent. This is a trick now. Now we can write it here. Note. Any compound or element, you can write here. Hope you are following now. Any compound or element that brings about reduction can be called oxidizing agent. Based on what we saw here. Did you understand? Now, why the reducing agent? What is reducing agent? Remember, we are still here. We are still here. I'm going to claim because we have a lot to do. We are still. This is number one. Number one. So I'm going to claim this. What is reducing agent? Reducing agent is the opposite of oxidizing agent. What did I say? If you know what oxidizing agent is, that means you should know what reducing agent is. Because oxidizing agent is a reversal. It's a reversal of what? Reversal. So now, reducing agent. we can say that reducing agent is any substance that is oxidized in a chemical reaction or equation, thereby bringing about reduction. So here we can say note, based on what we saw here, we can say any compound or element that brings about oxidation, uh, note, any compound or element that brings about uh, oxidation uh, can be called what? Reducing, can be called reducing, can be called reducing agent, can be called what? Did you understand that? Did you understand that? I'm going to give you another example to this. That is in the case of iron and 3 moles of iron and 4 moles of water. Can we quickly do it here? Can here contain it? Okay, let's try here. Another example. Let's call this example 2. When you have 3 iron plus 4 moles of water, you know this will give us this, right? This compound, this is 4. Then it's going to displace hydrogen. Hope you know. Hydrogen here is how many? 8. 4 times 2, 8. So here we're going to write what? 4H2O. Is that correct? It's correct. 4 times 2, 8. 4 times 2, 8. First thing is 4 here. So from here to here, what do we call this? This is oxidation, right? This is oxidation. What do we call this? Is it oxidizing agent or reducing agent? This is reducing agent. Now, from here to here, what do we call this? We call this reduction, right? What do we call this? Oxidizing agent. Now, let's look at this. Why do we call this ion reducing agent? Because it is one that brought about oxidation. So in the product side, oxygen was added to it. Why this water that is on the reactant side became reduced to hydrogen gas? That means oxygen was knocked out of it. So on this side, that is on the right hand side, which is the product side, we have 4 molecules of oxygen gas. Should I say 4 moles of oxygen gas? That is reduction. Now the one now that constituted the reduction, that initiated the reduction, should I say this stimulant of reduction is what? Oxidizing agent. Do you understand that? Good. All right. Let's enter this. next one, which is removal of hydrogen. Awesome. Well, pause again. Let's cover removal of hydrogen. Are you done writing here? But you are done with this side. Okay. So let's talk about removal of hydrogen. Because of the size of our board, I may be using one example instead of two because of the size of our board. Had it been our board is wide enough, I will still give up to 5 examples here. But because our board is small, I'll be giving one example each. You get? So now, I believe with the one example, you understand better. I may give two, depending. But I think one is better because of the size of our board. So now, number two is removal of hydrogen. Remember, we are still under the definition of oxidation and reduction. Removal of hydrogen. So here we can say that for oxidation is this is removal of hydrogen. Removal of hydrogen. While reduction is, you say this is addition of hydrogen. Addition of what? Hydrogen. Now, for example, let's consider hydrogen sulfide plus chlorine gas. They are gas and they are gas. And here, if this thing reacts, we're going to have 2 moles of hydrogen chloride plus sulfur. Is that correct? Yes. So here, we said removal of hydrogen. Removal of hydrogen. So from here, I think hydrogen was removed. Is that correct? And now from here, I think hydrogen was added. Am I correct? So removal of hydrogen, we'll call this oxidation. Is that correct? Now addition of oxygen, we call this reduction. Is that correct? Yes. Now, what do we call this? Is this oxidizing agent or reducing agent? Reducing agent. You know, the one that brings about oxidation. And we know that we say that reducing agent is any substance that is oxidized in a chemical reaction, thereby bringing about reduction. So is this thing now correct? Oxidation. Look at it very well. Addition of hydrogen. So hydrogen was added here. This is reduction. Removal. This is oxidation. So which one is oxidizing agent? Which one is? I want to confuse you now. Let me know whether you are following. This one. This will be reducing agent. This will be oxidizing agent. Okay, your own view. Eh? So you feel to be confused, right? Eh? I disagree. This one is oxidizing agent, this one is using agent. Prove me wrong. You are correct. This is reducing agent and this is oxidizing agent. I want to be sure whether you are following what I've been teaching you all this while. This is reducing agent and this is what oxidizing agent. Do you get that now? Why? Because this brought about oxidation. Remember what I told you, that any compound or element that brings about reduction can be called oxidizing agent, but it does not apply here. This one applies to addition of oxygen. So we are going to focus on this. Oxidizing agent is any substance that is reduced in a chemical reaction, thereby bringing about oxidation. Eh? So we have hydrogen sulfide here, eh? And it has been reduced to ordinary sulfur. And we have chlorine here. Eh? Now it is what? Hydrogen chloride. So hydrogen was added. Here, chlorine here is 0. The oxidation number here is 0. But here now, it is what? What here? Eh? Look at it here. We have 2HCl. Eh? If you are to find H alone, to find this alone, solving the oxidation number, this is +1 plus Cl equal to 0. Cl is equal to what? When +1 crosses Cl, it becomes -1. So chlorine here is -1. Why chlorine here is 0? Because it is neutral here. So that means, and you know that in terms of transfer of electron, oxidation is electron lost, while reduction is electron gain. So there was a gain here, there was profit here. So chlorine gain here, why here it was 0. Did you understand now? So here we have hydrogen sulfide. Now if you are asked to find the oxidation number of sulfur here, I think it is -2. Look at it here. We have H2X. So equal to 0. So this is 1 times 2 plus sulfur equal to 0. This is 2 plus sulfur equal to 0. Make sulfur subject of formula. Sulfur is equal to -2. Do you observe that here, sulfur here is equal to -2. Chlorine here is equal to 0. Now, chlorine here is equal to -1, while sulfur here is equal to 0. So look at it now. Look at it now. Here, -2. Here, 0. Did you understand now? Here, 0. Here, -1. Did you get? Do you understand? She's confused. What is your confusion?
Like here we have X is with hydrogen.
Uh,
And yes, I know that sulfur is -2. And here it's a no is neutral. This chlorine has 2 attached to it.
no, this two is a we have what we call diatomic element. Is a diatomic element, is a gas. So even here it is just 2, and that 2 means equal to 0. It is in neutral state. Here, sulfur has hydrogen gas attached to it,
So assuming in that chlorine we have hydrogen that's attached to it.
and here is sulfur.
Like I'm just talking about the chlorine.
Okay, assuming that it only has hydrogen gas attached to it. So we are not talking about, that means we're not talking about the removal of hydrogen there.
I'm just trying to get this and the state of it being neutral.
Okay, the state of it being neutral.
Yes.
The state of it being neutral is existing on its own without having something attached to it.
And it must have another element attached.
Yes, because we have what we call electronegative element and electropositive element. We have what we call radical. We have what we call ions. Do you understand? So I don't want to take you far. I want us to remember where we are till we get at that point where we will study transfer of electron, and all these half cell equations. And later we're going to do calculation on oxidation number. It is in this topic, but I'm going to extract it out of this topic. Yeah? And treat it separately as a topic. Did you get? So here now, in this topic, what I want us to learn here is just definition of oxidation and reduction under redox reaction as a separate class on its own, so that it will enable you to comprehend easily. Teaching everything will not do any justice to you. Do you understand now? So that is that on removal of hydrogen. Now let's go into addition of electronegative element. Are you ready now? Are you ready now? Huh? Now number 3, addition of electronegative element. Are you ready? Addition of electronegative element. Now, in terms of oxidation definition, we can define oxidation as addition of electronegative element and removal of electropositive element. For reduction, can call this removal of electronegative element and addition of electropositive element. I want you to grasp this definition before we continue. Let me repeat it again. It says that oxidation is addition of electronegative element and removal of electropositive elements. I believe you know what electronegative elements are. What are electronegative elements? Electronegative elements are elements that has negative charge, that are negatively charged. Remember you did ions, right? What is ions? Ions are elements that are either positively or negatively charged. And we have two types of ion. We have cation and anion. Cation are elements that are positively charged, and they can be called electropositive elements. That's another name for cation. While anions are elements that are negatively charged, which can be referred as what? Electronegative elements. You know them examples of cation are sodium plus, calcium 2 plus, potassium plus, magnesium 2 plus, aluminum 3 plus. While that of anions are chlorine minus, oxygen 2 minus, sulfur 2 minus, etc. Fluorine minus. Do you get? Good. So now, for reduction, we had that it is removal of electronegative element and addition of electropositive element. Now, let's take example. Let's take calcium plus chlorine. This is solid and this is gas. Two molecules of chlorine, and this will give us calcium chloride. Is that correct? Now, from here to here, and from here, from here to here. Now, let's look at oxidation before we write anything here and there. We are told that oxidation is addition of electronegative elements and removal of electropositive elements. In the polar side, we have calcium added to chlorine, right? Is that correct? And in the polar side, we also have calcium added to chlorine. Is that correct? So we can call here oxidation and call here reduction. Do you agree with that? Removal of electronegative elements and addition of electropositive elements. It's confusing, right? Look at her.
I understand that oxidation, but it's kind
Mm.
of confusing with reduction.
You understand?
The oxidation part, but it's kind of confusing with reduction.
You understand the oxidation part? What kind of confusing the reduction? Read this again.
Addition of electronegative elements and removal of electropositive
Hold
elements.
it there. What do you understand by that word? Addition of electronegative elements.
Adding all electronegative elements and then removing the electropositive elements.
Yes. Now let me use calculation to prove that. Calcium here is equal to 0, right? But calcium here, eh? Calcium here is 2 plus and chlorine here is minus. Hope you know. In terms of electron transfer, calcium is oxidized here, right? And chlorine is what? There is a gain, there is a loss of electron here. Even no, sorry, there's a loss of electron here. Because hmm, normal calcium is atomic number of normal calcium is equal to 20. But calcium 2 plus is equal to 18. Normal chlorine is equal to 17. But chlorine minus is equal to 18. Did you observe something here? Calcium here, let's take away neutral state and all that. Let's use normal particulate nature of matter now to observe this. Atomic number of calcium here is 20. Atomic number of calcium here is 18 because it is oxidized now. There is a loss of electron. So that is why we say here is oxidation. There is a loss of electron because it is in combined state here. So here now is what? 18. There's a transfer of electron. And here is reduction. Here is reduction. Are you following now? Because chlorine here is 17. Here now it is 18. Did you get? You've understood it now. So what do you call this? Is this one oxidizing agent? Why do you say reducing agent?
I said reducing agents because like oxidation brings about reduction of
You said reducing agent because what?
oxidation brings about reducing agents.
Oxidation brings about what?
Reducing agents.
Okay. Because oxidation brings about what?
Reducing agents.
Okay. Oxidation brings about reducing agent. So here is reducing agent. And what do you call here?
Oxidizing agent.
What is the reason for being oxidizing agent?
Is oxidizing because um is oxidizing because reduction brings about oxidation.
Confirm. That means you understood it. It is clear now, right? So we're going to we'll move on to the fourth one, which is transfer. Transfer of what?
I'll let you.
Are you done writing?
I'm here.
Okay, write quickly. Transfer of electron. So I can clean here, right? I think this is the last one.
Yes.
So I will stop here. So in our next class, we'll treat half cell equation, half equation separately. Do you understand? Okay, the last but not the least is what? Transfer of electron. Is that correct?
Yes.
Now, we can say that this is the concise definition of redox reaction as it refers to transfer of electron. And this transfer of electron simply means electron loss or gain, depending on either oxidation or reduction. Did you get that? So here we're going to talk about transfer of electron. This is a blueprint of redox reaction. It is a springboard, the bedrock of this. Now, here we're going to use the example. Let's use 2 moles of iron chloride plus chlorine. This is solid. And this will give us how many chlorine do we have here?
4.
4 chlorine. 2 times 2,
Yes.
4 plus 2, 6.
6.
I have taught you balanced non-chemical equation, right? So this is 2 iron. So I want you to know that this is iron 2 chloride. This is what? Iron 2 chloride. And this is iron 3 chloride. This is iron 2 chloride and this is iron what? 3 chloride. Is there increase?
Yes.
Is there increase?
Yes.
Is there decrease?
No.
Now, that means from here to here is oxidation. Is that correct? Is that correct? And from here to here is reduction. Prove me wrong. I want you to understand this. Look at it very well. Look at it very well.
There was an increase in this one, so does it mean that oxidation goes with increase, like gain?
Goes with increase like gain.
And
You said there was an increase in which
and the
one?
product,
In the product.
yes,
Which of the product?
the one on the right hand side,
Is there a particular element that
yes,
you discovered?
chlorine,
Chlorine. There was increase in
yes,
chlorine. Okay. What about iron?
iron remain constant,
Remain constant, right?
yes,
Now that means we pinpointed chlorine here, right,
yes,
as our case study to weigh the authenticity of this loss and gain, as it refers to this in relation to this transfer of electron. Remember I said that electron loss is what? Oxidation. Electron loss is oxidation and electron gain is
reduction,
reduction. Did you understand? Now iron 2 chloride reacted with chlorine to form iron 3 chloride. Is there an increase?
there is an increase in the product. Iron 2 chloride reacted with chlorine to give iron 3 chloride.
That means there was an increase in chlorine.
Yes,
Is it electron loss or electron gain?
electron gain is
So what do
the
you call that?
reduction.
What is this, right?
Mm.
Yeah? That is reduction, right? Now, for oxidation, is there electron loss?
Oxidation.
Yes. No.
No.
Yes, there's electron loss. Prove it. Because this one now is reducing agent. Are you aware?
Yes.
And this is oxidizing agent. Eh? That is iron 2 chloride reacted with chlorine to form iron 3 chloride. Like the oxidation number. The oxidation number. What is the oxidation number here? Eh? I'm not sure. What is the oxidation number here? Yes, it's three. Eh? Is what? You know, we are considering chlorine on both sides.
Mm.
Like you said, iron is constant here. We are considering chlorine on both sides because iron 2 chloride reacted with chlorine to form iron 3 chloride. Yes. So the oxidation number of chlorine here is what? It is 2 now. Yes. 2 times minus 1. When it crosses the other side, it becomes plus 2. Now 3 times minus 1, the other side what? 3
Three.
plus 3. Do you get? So this, in this case, this is transfer of electron. So this is in terms of electron loss or gain. Did you understand that? So I will not take you deep into this. I want you to understand this this peripheral level of redox reaction in terms of definition of oxidation and reduction. In our next class, we will dive very deep into um, what was that one I made mention of? the one I aforementioned, have cell reaction and the steps to have cell reaction, which after that we are going to solve questions on redox reaction. Then for oxidation calculation on oxidation number, I will treat it separately, though there is a connection there, but I will treat it separately. So thanks for watching, and please don't forget to subscribe to this channel and give this video thumbs up. See you in my next video. Bye.